on the market this year. Today, I'm going to talk about the paper Option Momentum. It's a joint work with Steve Heston. All right. So in this paper, we study the momentum effect in option market by constructing a portfolio of daily hedged options. We call this portfolio VIX Portfolio. And there are two components in this portfolio. One is a static position in a portfolio of tradable out of the money options. And also there is a daily hedge component in the underlying stock market. We show that the portfolio payoff could closely approximate the realized variance of the stock return. And since we only use tradable options with real market price to construct this portfolio, we could compute the actual return of this portfolio. So this is different from the synthetic variance swap return used in previous literature. And the VIX return could be viewed as an option analog of the CRSP monthly stock returns, except that we are using VIX return to measure variance risk premium in option market instead of equity risk premium, okay? Then we apply this technique and compute VIX return, which is the actual return of VIX portfolio for the SP 500 stocks. Then we look at the cross-sectional VIX return and we find a momentum effect and a quarterly seasonality in the option market. Specifically, we find that the option momentum lasts for up to 5 years, and there is no 1 month short-term reversal and long-term reversal. This is different from the stock market momentum, which has been shown to last for 1 year by Gigandish and Titman, and would reverse beyond 1 year. Okay, option momentum does not reverse. And in addition, we find there is a quarterly seasonality in VIX returns. So the firms tend to have relatively high or low returns every 3 months. This is different from the annual seasonality documented in the stock market by Heston and Sedgwick, 2008. Okay. All right. This paper is related with variance risk premium literature. Bakshi and Kapadia, 2003, they link the volatility risk premium with delta hedged option returns. And when they do the hedging, they use Black-Scholes delta. So the hedging is model dependent. And also the delta hedged returns could differ by the moneyness of option contract. So they need to pick the moneyness of the option contracts. And Boleslav, Tolkien, and Joe, 2009, use the difference between VIX square and the realized historical variance to measure VRP. And they show the variance risk premium could predict aggregate stock market return. Carr and Wu, 2009, they construct a continuous option portfolio, assuming a continuum of strike price. And they use this option portfolio to approximate the payoff of a variance swap contract. And they calculate the variance swap return as the realized variance scaled by the VIX square. So this return is a theoretical return because it requires the interpolation of thousands of non-traded options in the option market. In the VIX portfolio, this paper, we only use the tradable option contracts with real market price to construct the VIX portfolio so that we could compute the exact return of the VIX portfolio instead of theoretical return. This paper is also related with momentum literature just mentioned. Okay, so next, let me start with the construction of VIX portfolio in this paper. The starting point is Carr and Madan 98 paper. In that paper, they construct a continuous option portfolio, which is the left-hand side in equation 1. So the O in the numerator is the option price at strike price K, okay? each option in the portfolio have a weight 2 over the squared strike price. They show the terminal payoff of this option portfolio would equals the log contract payoff plus a static hedge position in the underlying stock. The ST here is the stock price, and the RF is the daily risk-free rate. Okay, the static hedge is today we borrow the present value of $1 and invest in the underlying stock and hold it to maturity. What we did is to split the log contract payoff into a daily summation. This is true by telescoping sum, and then we replace the static hedge with a daily hedge. The daily hedge is each day we borrow $1 as a risk-free rate and invest in the underlying stock. So this daily hedge is model-free because the delta of the log contract payoff is 1 over S, equivalent to investing $1 in the underlying stock each day. And we apply Taylor's expansion daily. The left-hand side would approximately equals the sum of squared daily return, which is the realized variance of the stock. Okay. Then we construct the equity VIX portfolio used in this paper. First, the VIX portfolio has a static position in a portfolio of options. The portfolio price is as in equation 3. It is a discrete version of the current Mardan continuous option portfolio. Here, the O is the option price, and the delta KI is the strike interval. Okay, and in this portfolio, we only use the traded option in the real market that has a market price. There is no interpolation going on when we construct this portfolio. And in addition to the option position, the VIX portfolio also has a short position in the static hedge and long the daily hedge component. Based on equation 2, the actual payoff of this VIX portfolio would approximate the realized variance of the stock return. And we could compute the actual return of the VIX portfolio as in equation 4. We call this equity VIX return. And this is the testing portfolio in our paper. Okay. All right. For the sample, we use option metrics database from 1996 to 2017, and we compute the VIX return for SP 500 index and its constituent firms. The VIX portfolios are formed on third Friday each month and held to third Friday next month, which is when the monthly options expire. In this case, there is no interpolation across maturity going on. We are just computing the hold to maturity return of this VIX portfolio. That's an actual return. Then we filter options following the CBOE white paper. In addition, we delete illiquid options following standard in this literature. Okay, that's the sample construction. All right, this is summary statistics. On average, we have around 300 firms each month, and in each VIX portfolio, we have around 6 option contracts. To check how closely the VIX portfolio payoff is related with the realized variance, we compare the VIX return, which is the actual return, with synthetic variance swap return used in previous literature. Is defined as realized variance scaled by the VIX price. Okay. First, if we compute the VIX return for SP 500 index, the difference between index VIX return and index variance swap return is small. They are both largely negative. The monthly average return is negative 23%. And they have a correlation of 0.99, highly correlated. if we look at the individual firm, the difference between the VIX return and the variance swap return is larger because here we have fewer option contracts traded on individual firm level. But by forming equally weighted equity VIX portfolios across firm each month, the approximation error could be diversified away to some extent. And for the equally weighted portfolio, the difference between VIX return and VSR is much smaller. And the two have a correlation of 0.92. The difference is 0.23% on average each month. Okay, so the approximation is reasonable. Then to check for each individual firm how closely the VIX return and the VSR co-move with each other, we compute the time series correlation for each firm. The average correlation is 0.75 and the median is 0.87. So even on individual firm level, the two co-move with each other. All right, and if we look at the firm level VIX return exposure to the individual stock, on average, they have a negative exposure to the individual stock. This resembles the negative correlation between aggregate stock market return and the variance swap return for index. And also, the exposure of equity VIX return to index VIX return is positive, 0.4. So the equity VIX return has a positive exposure to the market variance risk. So the overall, the evidence suggests that the equity VIX return is a close measure to the variance risk premium in option markets. Okay. All right. Next, we apply this technique and compute the VIX return for SP 500 stocks and document momentum in option market. We follow the classical methodology in Gigantish Tiedemann 93 paper. We use their JK months strategy. Each month, we sort firms into Decile by their past J months VIX return. Then we hold winners VIX portfolio and short losers for the following K months. Firms are equally weighted. Since the option position in the VIX portfolio expires each month, we need to rebalance the portfolio each month and maintain a equally weight. Okay. So this table shows the returns of the strategy under different combination of formation and holding period. The numbers are the average monthly returns in percentage. We find positive returns for each strategy, and the past winners outperform past losers. Here, the 3-3 means we sort by past 3 months VIX return and hold the firms for the following 3 months. Okay, on average, this strategy delivers a 10% monthly return, and as the time extends, the return of this strategy start to decrease. So the same is true if we extend the sorting period. Okay, it would decrease. Overall, the evidence suggests that there is momentum that exists in option market. All right, next, we try to examine the source of momentum profits. We decompose the variance swap return into a realized variance component and a VIX price component. To check how each component could be predicted by their own lags, we run cross-sectional regression on each component. So specifically, we regress the realized variance or the VIX price on their own K-month lag. And the coefficient gamma measures the average response of realized variance to their own lag. Okay, so we plot gamma coefficient with respect to the month lag K, And this is a graph we get. So here the orange dotted line is the coefficient on the lagged VIX price, and the blue line is the coefficient on lagged realized variance. They are both persistent and they display a quarterly seasonality. Okay, so the realized variance and VIX tend to be high or low every 3 months. And the VIX price is more persistent than the realized variance, suggesting that the option price may not fully anticipate the persistence in the realized variance of the stock. All right. To check this, we run the cross-sectional regression using log variance swap return directly. And we find a large positively significant coefficient that lasts up to 5 years, okay, 16 months. And there is a sharp quarterly seasonality pattern. So, and in addition, there is no short-term or long-term return reversal in the option market. This is different from the stock market, in which you would observe there is a large negative coefficient in the first month and a negative coefficient beyond first year lags. Okay. All right. So in the previous regression, we only include the lag of a certain month each time. So to check the incremental statistical significance, we include all 12 months lags into a single multivariate regression. And the t-stats are shown in the last column here. Okay, so we can say the t-stats are highly positively significant for quarterly lags, so which are the 3, 6, 9, and 12 months lag relative to other non-quarterly lags. So for non-quarterly lags, they are less positively significant. But in the univariate regression, they are all highly positively significant. Okay, so this says the quarterly seasonality contributes a lot to the option momentum. Okay, so next we try to exploit the pattern we documented in the figure before by forming Decile portfolios. Each month we would sort firms into Decile by their past log variance swap return and equally weight firm and hold the firms for 1 month. To check the seasonality, we sort by 3 past return categories. First, we sort by all the past 12 months log variance swap return during the year. And in addition, we sort only by the quarterly lags, so which are the VSR at months 3, 6, 9, and 12. And in addition, we sort by non-quarterly lag. Okay, so this is 3 is our sorting variables. We do the portfolio sort for the past 5 years. So here, the year 5 means we only use the past returns from 48 to 16 months to do the portfolio sorting. Okay, and for year 1, we observe there is a monotonic increasing pattern from the past loser to past winners. The past losers have an average negative 13% monthly return, and the past winners have on average 2% monthly return. A long-short portfolio strategy delivers a highly positively significant return, which is 16% monthly, and the t-stats are around 8. Okay. If we sort by all past return during the year, the strategy would become unprofitable starting from year 4. The t-stats equals 1.68. But if we sort by quarterly lags, we would find positively significant returns in nearly all past 5 years, except in year 3, the t-stats are lower. But in year 5, we find a 6% monthly return with T-stats equal to 3.46. So the seasonality lasts up to 5 years. On the other hand, if we sort by non-quarterly lags, the strategy would become insignificant starting from year 2. The T-stats drop to 1.48. Okay. Then we want to check if the momentum profits could be explained by risk factors. We control for Fund 3 factors, stock momentum, and also the index VIX return. The alpha we get is close to the raw return of the portfolio. So the momentum profits cannot be explained by the risk factors we control. Okay. All right. Then we look at the risk-adjusted return. The winner has a 12% alpha, which is much larger than the negative 5% of the loser. So most of the momentum profits are actually coming from a winner portfolio. And the long-short portfolio have a low exposure to stock market risk factor, but a slightly positive exposure to the index VIX return. So next, we want to check if the momentum could be explained by other option return predictors documented in previous literature. We start with Guios-Retto 2009. In that paper, they find the log difference between historical volatility and the implied volatility could positively predict cross-sectional option return. Since they look at the as-a-money straddle return in that paper, the implied volatility is calculated using only as-a-money options. In this paper, the equity VIX portfolio includes options from all moneyness. So we replace their as-a-money implied vol with VIX price. And this variable resembles a value factor in option market. The book value of firm's variance is their historical realized variance, and the market value of firm variance is the VIX price calculated using option price. And the momentum, for momentum, we use the past 12 months log VSR to proxy for option momentum. So in each month, we first sort firms into quintile by value, and then within each value quintile, we further sort firms into quintiles by momentum. We find positively significant profits in every quintile, except in quintile 3. Here, the alpha is insignificant, but overall, the evidence suggests that the option momentum cannot be fully explained by option value. Okay. All right. Then next, we try to control for other firm characteristics that has been shown to predict option returns. Well, we include them in a cross-sectional regression. Those variables, control variables, includes the idiosyncratic volatility, which has been shown to negatively predict cross-sectional option return. And we also include a higher order moment of the stock return, like the skewness and kurtosis, to control for the liquidity of the underlying stock. We use Amihood illiquidity measure. And we control for the demand pressure in option market by using the average open interest of the firm's option during the past week, scaled by the stock trading volume. Okay. And we also include other characteristics like the past stock returns, size, book to market, and other characteristics. So to make sure that the result is not unique to the newly constructed VIX portfolio in this paper, we use additional testing asset, which is the delta hedged as a money call or put returns constructed following Bakshi and Capadia 2003. Okay, the option momentum is still the average past 12 months log variance swap return. And in this cross-sectional regression, we use option momentum to predict the 1 month ahead equity VIX returns. Okay. This table shows the coefficient estimate and the t-stats for each predictors. In column 1, we can see the option momentum positively predict cross-sectional equity VIX return. And controlling for all the other characteristics only slightly change the coefficient estimate and the t-stats of option momentum variable. For delta hedged call or put return, we get the same pattern with similar t-stats. So this is a robustness check to make sure that momentum cannot be fully explained by other option return predictors. So last, we consider the impact of bid-ask spread because the percentage bid-ask spread in option market is large. We do this by consider effective spread as a percentage of quoted spread. Specifically, we consider 3 thresholds when the ratio equals to 50, 75, or 100% of the quoted spread. The 100% means we buy option at ask and sell option at bid. The 0% means options are traded at the midpoint price. Okay. For all and quarterly strategy, at the 50% threshold, they are still positively significant. But if we consider the whole bid-ask spread, all 3 strategies become insignificant. In a paper by Muravyev and Pearson, they find that for traders who could time their execution by the public information, their effective spread are less than 40% of the conventional measure. So for those traders, the all and quarterly strategy may still be profitable. We could further avoid the illiquid option contracts by only trading the VIX portfolio whose percentage bid-ask spread is lower than the median. Okay, in this case, all the 3 strategies would be profitable at the 50% threshold, and the strategy sorted by all past year variance swap return and the quarterly lags are still profitable when we account for the whole bid-ask spread. Okay. All right. Okay. Let me conclude. So in this paper, we compute the actual return on model-free daily hedged equity VIX portfolios. When we construct the portfolio, we only use tradable option contracts with real market price, so that we could calculate the actual return. It's different from synthetic return in the previous literature. And we empirically show the portfolio payoff would approximate the realized variance of stock return. After computing the VIX return for SP500 stock, we find a cross-sectional momentum in option market, which is different from the stock momentum. The option momentum lasts for up to 5 years, and there is no short or long-term return reversal. In addition, we find a quarterly periodicity, and this quarterly periodicity lasts for 5 years. It's different from the annual seasonality in the stock market. Okay. Yeah. Thank you.
So great. Thank you very much. There are a few questions in the chat that I'll read now, but after I do that, anyone else should feel free to unmute themselves and ask their questions using the microphone. Okay, so the first question in the chat from Aurelio Vasquez. How do your VIX returns compare with delta hedged option returns? And Aurelio also makes an observation that there's another paper by Chris Jones and Haitao Mo and Mehdi Karam that has the same title. So what's the relationship between your paper and this other paper?
Okay, so when you ask the delta hedged return, I guess maybe you refer to the Berkshire and Capadia.
I think Aurelio's talking about that measure of option return. Yes.
Yes, that paper. Yes, for to compare with delta hedged option return, Berkshire and Capadia show the return of that delta hedged portfolio could differ when you choose different option contracts with different moneyness. Okay, so each time when they do the delta hedging, they pick a certain option contract with a certain moneyness. So in the VIX portfolio, it's constructed in a model-free way in which you include all the option contracts from all the moneyness. Right.
Right.
So
I thought his question. Oh, so maybe I misunderstood his question, but I thought he was getting at, what's the correlation roughly between delta hedge returns and your VIX return? Are they really capturing the same thing?
The correlation, I forgot the exact number, but it is high, around 0.8, I guess. And when I use the delta hedged option return as a robustness check, you can see in this table, the coefficient estimates have similar t-stats for option momentum and so for other predictors. So on average, I would say they tend to capture similar information about the variance risk premium.
Okay.
Yeah, for the other question, I think it's a comparison with another paper, right? But sorry, I didn't really read that paper. Maybe I need to read it first before I can say something more. But in this paper, we are looking at the cross-sectional option momentum. I don't know if it's what that paper does. So yeah.
Okay, so let's leave it there. So let me ask a clarifying question here. Is IVOL here idiosyncratic volatility?
Yes. Yes.
Okay, so that might answer Dimitri's question, which was, does stock volatility matter? But anyway, I'll let Dimitri re-ask it if he wants to. Go ahead. And then the next question is also from Dimitri. How did the anomalous returns change over the sample period, right? Presumably, over your sample period, the option market became more efficient and more liquid?
Yes, I think yes. So for the later period, when the option market becomes more efficient, there would we would observe a relatively lower average momentum profits. Yes.
Okay, so that's related to my question. So, I mean, it seems to me your paper is just documenting these returns, just documenting the fact. But do you have an explanation in mind? Do you think this is some behavior? Do you have a behavioral story in mind? Do you have a risk-based explanation in mind?
In this paper, we are not really digging deeper along that direction. So, but based on the risk-adjusted return of the loser and winner portfolio, it seems that there are anomaly on both legs, right? And most of the profits coming from winners. So it's possible that the option market participants keeps underestimate the stock volatility. And in that case, the option price tend to be underpriced. It's possible. And it's also possible there may exist a time series momentum in this anomaly. Yeah. But we didn't do too much work on that in that direction.
Christian here. I want to continue on this question. I think I would be careful about calling this an anomaly. I mean, it feels it could.
That was Dima's word, not Shuaiqi's.
No, I know. But
okay.
We used it in the. Anyways, it's just I think there might very well be a risk-based explanation, and controlling linearly for other factors of risk might not capture what's going on in option markets. That's just my 2 cents comment.
I see. So if you, as to if this is an anomaly, so yeah, but how do you think about the stock market seasonality? So we know there is a 12 months annual seasonality in stock market, right? So previously people would view it as an anomaly, but of course there are some risk-based explanation. Maybe the risk premium also have a periodicity, something like that. But in this paper, there is also a quarterly seasonality. So there could potentially be an anomaly, but in the paper, I don't think we call it anomaly explicitly, yeah, because we didn't do too much check on that. Yeah, we are just trying to document.
Yeah, you're careful about that. That's good.
Thank you.
Okay, from Tobias Sitchert, I'll just read it. Maybe I misunderstood the methodology, but is there a correction for expected returns? That is, are past returns excess returns?
Past return. You mean when we construct the VIX portfolio, or when we run?
Well, actually, I think the answer is maybe that you're doing the benchmarking to these market factors, right? That's the risk adjustment.
So when we look at the Decile portfolio return, we did adjust for the risk factors like the index VIX return. I don't know if that answers the question. So here we include the excess return of the index VIX.
Right. So that's the risk, right? Okay. So you say you have excess returns relative to this factor model.
Yeah. Yeah. Yes.
Okay. So other questions? No other questions. Okay. Last chance to ask a question. Last chance for the authors of the other paper to make a comment. Okay, then I will move to the next speaker. Oh, good. You okay? You freed up the screen. Here is I'm